Hi everyone, today's video topic is switch expressions. Switch expressions are a pretty new feature to Java, and they've gone through various previews and updates over the last 5 or 6 versions of the JDK. And today I want to talk about switch expressions, not every single little gotcha, because they're still actively getting previewed, but I want to cover some of the basics. And to do that, I'm also going to cover switch statements, because to understand a switch expression, you kind of have to understand the basics of a switch statement and what an expression can get you versus a statement. So I'll cover both of those today. Let's get into IntelliJ and look at some code. Today's project will be called switch expressions. Now for this video, make sure that the JDK you're using is relatively new. I'm using 19. You could also use 20 because at the time of this recording, that's the latest version. Just make sure that you're using a newer JDK, something a lot newer than 8 or 11, something like 17, 18, 19, or 20. So the first thing I want to cover is switch statements. These have been around since the very first version of the JDK, and that's what most people think of when you see the keyword switch. So what I'm going to do is I'm going to write a switch statement that switches over the days of the week and then prints out a statement based on which day it is. So this is what most people think of when they see switch. They think of a switch statement. And that is you have an expression here, which is you're evaluating an enumeration. Specifically, I'm looking at the day of week enum within the Java time package. And you go over each of the enum cases, and then you have a default here. And then you have these break statements, because if you were to omit the break statements, and let's say it were Monday, then you would go into the next statement after that. Let me go ahead and run a few examples just so that we can see how this all works. All right, so in this case, because it's Monday, we hit the first case, it's Monday, and then we move on after that. If I were to set this to Thursday, we can see that we hit the Thursday case right here, and we say it's Thursday, almost Friday. And then likewise, if we were to do Sunday, even though we don't have it included in the list of cases, we do cover it because we have this default case down here. And then if I were to put in null, let's see what happens this time. We get a null pointer exception. That's because when the switch statement is evaluated, it checks the value of the expression to see if it matches the case statements. And instead of actually hitting the default case like some might think would happen, it actually throws a null pointer exception. Because as you can see, it says right here, it's trying to invoke Java time, day of week ordinal. But the day field is null, therefore it can't actually execute that. So that's a little bit of background on the various things that you get with a switch statement and the benefits and costs to that. In addition, let's say I didn't want to print all these out and I just wanted to store this as a variable. I'm not going to rewrite all the code because that would take a while, but you can imagine if I had a string variable that was called result, and I wanted to set result to each of these things and then manipulate result or something like that, I'd have to change it for each of these case labels, and that takes a good bit of code. Those are some of the downsides of the existing switch statement, and now I'm going to talk about a switch expression. So the first thing here is I'm going to change this back to Monday, and if I hover over this, the IDE is saying that I could replace with enhanced switch statement. So I'm gonna go ahead and do that. Whoa, okay, so what just happened here? Well, we just converted this from a regular old switch statement that we were used to into what is now considered an enhanced switch statement. It is using this arrow syntax, and you'll note that we don't have to include the break statements anymore. And I don't know about you, but I think this code is a whole lot more readable. So let's go ahead and run it and make sure that nothing has changed. Cool, so now we can see even though we don't have breaks in between each of these case statements, the arrow syntax, basically what it does is it puts the scope of the next set of logic that comes after the arrow within its own group, and you don't have to include a break. And you might be thinking, okay, well, one of the benefits of a switch case statement is if I wanted to add scoped variables or things like that, I could do that. Well, you can do that here as well. So let's say I want to do this instead. This code still works as well. The one thing that this doesn't solve is if I set this to null again, we'll notice that we still get the null pointer exception in this case. The gist of a switch expression is instead of this statement not having any sort of return value, you can actually change that in order to have the switch return something. So I was talking about how we could have a result variable that holds the value of all of our different cases. If I were to do that with the original switch statement, that would take a lot of extra code and it would be some refactoring. With a switch expression, it's really not all that bad. All right, now to demonstrate that this is working, I'm gonna go ahead and switch this back. I've done Monday enough. I'm gonna switch this to Tuesday. And then here at the end, we have to add a semicolon now that it's a switch expression. And I'm gonna go ahead and print out result. And now instead of having to call print in all these different cases, I just grab the result and I print it out at the bottom. All right, very good. I don't know about you, but when I compare the first version versus this version is way easier to understand and to read. So already we're seeing some great improvements with a switch expression over a switch statement. Now, one of the other beautiful things about a switch expression is that it can handle null values. So now what I want to do is I want to say if my value is null, I'm going to go ahead and return that. But if I hover over this, what's going on? Patterns in switch are not supported at language level 19. Ahaha. So what's going on here? Well, when preview features are added into the JDK, and this is a preview feature as of JDK 19, you need to explicitly tell your IDE, or if you're running Java on the command line or a configuration file, you have to notify it that you want to turn preview features on. So we're going to go ahead and do that. And with IntelliJ, what you do is you set language level to 19 preview. And now we'll see that error has gone away. And I will run a test quickly and demonstrate what the new behavior is. Excellent. So now instead of having to worry about null checks on my data members before I enter the switch expression, I can include the null check actually as a case within the switch expression itself. So now the next thing I want to talk about is that switch expressions added a contextual keyword called yield. And what do I mean by contextual keyword? Well, a lot of keywords are keywords because they mean something in the context of a particular usage of the language, and you can't use them for variable names or other purposes in your code because when the compiler is compiling your code, it needs to look for that keyword in order to determine what you want to do. A contextual keyword means that it's a keyword only in the context of certain situations. Otherwise, you can still use it within your code for variable names and the like. So the contextual keyword that was added with switch expressions was yield. And yield is used in two situations. The first one is when you are using the regular colon syntax, you can yield a value. And when you are using the arrow syntax, whenever you have more complex logic within bracketed statements, not like this, I'll demonstrate here in a second, then you can use the yield keyword to basically return a value back for a certain case label in your switch expression. You might be thinking that sounds a lot like return. Well, it does. The reason that they don't have return there is because that would get ambiguous. Are you returning out of the switch expression or out of the method? And in the first time that switch expressions were debuted as a preview feature, originally yield wasn't available and it was called break. So there was a break statement which then had a value. And the feedback from the community is that that was confusing, so the language designers then went and changed it to use the yield keyword instead. So to demonstrate yield, I'm going to go ahead and make brackets here, and now it's saying that it doesn't know how to evaluate this. If I just type in yield, this works, though the IDE is telling me that this is redundant because I could just replace it with the code I had originally. So now I'm going to say something like adding more logic in here. And even though I'm just printing something, now the IDE is saying that that's fine because really what we're doing is we can't just easily replace this logic with the original enhanced syntax, and we need to add in a little bit more in here. So for instance, let's say that after you hit your case label, if you wanted to do some additional manipulation on the data, you could do that within this block and then yield a result to the switch expression. So as we can see, when we execute the code, we print out this message and then we yield the value to the switch expression. We go all the way down and then we print the result. And that's what we see here. Now the other case of yield is if you have a regular case statement like this, then you would want to use yield as well. And it would look like this. Now, what's going on with this error? Well, when you make a switch statement or expression, you need to be consistent on whether you're using the colons or the arrows. And it says here different case kinds used in switch statement. So you either need to use all colons or all arrows. Now, I'm not going to refactor the whole switch expression, but I think you get the idea. So with that, the last thing I want to cover is pattern matching within switch expressions. So let's say you have a problem where you have an object, and I'm going to set it to a value of 10. So what this is doing is this is an integer primitive, and then it is getting boxed into an integer class type, and then it is getting upcasted to object. And let's say that I want to print out the value of this object as double. And I'm going to go ahead and create a method called asDouble that takes an object, and it's going to return a double. So I'll just do this for now. And now you might be thinking, okay, how would you go about solving this? Well, the first thing you might do is you might try to figure out what type of class your object is, and then you would do some downcasting. So you could do something like if object instance of double. And there's also the concept of pattern matching with instance of, and that allows us to set a variable within the instance of statement and not have to have a separate downcast item later. So in older versions of Java, what you'd have to do is if this is true, then you would create double object equals double object. And this takes 2 lines of code. But in later versions of Java where you have pattern matching with instance of, you can do this all in 1 line. And now if I were to enter that if statement, I now have a double object variable name who is a double, and I know that object is an instance of double. So if this is the case, I just want to return double object. How about if object is instance of a number? So what I can do in this case is I can say num object dot double value, and if object is a string, and what I can do in that case is I can say double dot parse double string object. And then what I'll say here is because instance of also does null checks, if I were to pass in a value of null into this method, I'm just going to go ahead and return 0 for now just for simplicity. Let's go ahead and run this and see if it gets what we want. All right, so that looks good. What if I replace this with math.py? That looks good. And similarly, if I change this to a string value of 23.981. Okay, so I think I've shown that the code here works as expected. That's cool. And the pattern matching on instance of is nice because now I can look and I can do this in fewer lines. But I could make this even a little bit simpler, and I could convert this into a switch expression. Ah, that cleans up pretty nicely, doesn't it? Note that what we're doing within our case labels is we're also doing pattern matching. So instead of having to do the explicit instance of checks, we can declare a type that is a potential downcast of our variable here, and we can see that it attempts it, and if it works, then we yield the value for that associated case statement. That's cool. And if you look carefully, there's actually an error here. Switch expression does not cover all possible input values. Cool. So what this is doing is it is making sure that we prevent code bugs. If you looked carefully, the previous code was if, else if, and then a return of 0. So there was no else case. So what it would do is if we didn't have any of the code hit the existing branches, we would just default to 0. When instead, now we can explicitly add in default case and figure out what we want to do here, and the compiler forces us to do that, whereas before we may have had an actual code bug. So in this case, I want to add default, and I'll go ahead and throw a new illegal argument exception. Cannot convert to double. And then I'm going to print the object's class information. And I know that I can do this because I already did a null check. So I know that I don't need to do any null checks here. I can instead just call get class directly. And this looks a good bit better. Let's go ahead and run the code and make sure everything still looks good. Cool. Now, let's say that I want an integer. Let's give an integer value of 13. Excellent. Now, I want to change the code a little bit. Instead of calling number here explicitly, I want to call integer here, int object, and I'm going to go ahead and do that. Okay, so why is there an error here? Label is dominated by a preceding case label. Again, the compiler is actually doing us a real favor here. If you look at what pattern matching is doing, we're essentially doing instance of checks. So because an instance of applies to a class's parent class as well, what can happen here is even though we're doing the same logic, really it would evaluate number first. And because all integers are numbers, the integer would never get hit here. Again, if you just had if-else if cases, that would be another code bug, but instead the compiler is catching it for you. I think that's pretty neat. And that was an overview of the highlights of switch expressions. And honestly, the feature set is continually evolving. So it's one of those things where it's good to stay on top of what the language designers are doing and what they're proposing in later versions of the language so that you can figure out how to update your code and make it more efficient. I know that I'm sure excited to use these newer language features and add them into my code and figure out where they make sense to use. I'm really big on being a quote-unquote lazy programmer and letting the tools do the work for me as much as possible. And I see switch expressions as a way of doing that because the compiler enforces some rules for you that makes it easier to avoid code bugs. With that, I'm going to wrap up today's video. I hope you have a good rest of your day, and I hope to see you next time. Take care.